So here's a quick overview of shared VPCs. Shared VPCs allow organizations to connect resources from multiple projects to a common VPC network, so they can communicate with each other securely and efficiently using internal IP addresses from that network. When you use shared VPCs, you designate a project that'll be the host project, and then you attach one or more service projects to it. The VPC networks in the host project are called shared VPC networks. Eligible resources from the service projects can use subnets in the shared VPC network. Shared VPC lets organization administrators delegate administrative responsibilities, such as creating and managing instances, to service project admins, while maintaining centralized control over the network resources like subnets, routes, and firewalls. This model allows organizations to do the following: implement a security best practice of least privileges for the network administrators, auditing, and access control. Shared VPC admins can delegate network administration tasks to networking and security admins in this shared VPC network without allowing service project admins to make any network impacting changes. Service project admins are only given the ability to create and manage instances that make use of the shared VPC network. It also allows organizations to enforce consistent access control policies at a network level for multiple service projects in the organization while delegating administrative responsibilities. For example, service project admins can be compute instance admins in their project, creating and deleting instances that use approved subnets in the shared VPC host project. Companies can use service projects to separate budgeting for internal cost centers. Before we continue, let's summarize some of the key concepts. Shared VPC connects projects within the same organization. Linked projects can be in the same or different folders. But if they are in different folders, the admin must have shared VPC admin rights for both folders. A project that participates in shared VPC is either a host or a service project. A host project contains one or more shared VPC networks. A shared VPC admin must first enable a project to be a host. After that, a shared VPC admin can attach one or more service projects to it. A service project is any project that has been attached to a host project by a shared VPC admin. This attachment allows it to participate in shared VPC. It's a common practice to have multiple service projects operated and administered by different departments or teams in your organization. A project cannot be both a host and a service project at the same time. This means that a service project cannot be a host project to any other service projects. You can create and use multiple host projects. However, each service project can only be attached to one single host project. And lastly, a project that does not participate in shared VPC is called a standalone project. A shared VCP network is a VCP network defined in a host project and made available as a centrally shared network for eligible resources in service projects. Shared VCP networks can either use auto or custom mode, but legacy networks are not supported. When a host project is enabled, all of its existing VCP networks will become shared networks, and any new networks that are created will automatically be shared as well. That means a single host project can have more than one shared VCP network. Host and service projects are connected by attachments at a project level. Subnets of shared VCP networks in the host project are accessible by service project administrators. Shared VPC host projects are subject to standard per project VPC quotas. They are subject to per network limits and per instance limits for VPCs as well. And additionally, the relationship between host and service projects are governed by the limits specific to shared VPC. Billing for resources that participate in shared VPC networks is attributed to the service project where the resource is located, even though the resource uses the shared VPC network in the host project. Here are a list of eligible resources that can participate in shared VPC, as well as some practical limitations. Let's talk about VPC network peering. GCP Virtual Private Cloud Network Peering allows private connectivity across two VPC networks, regardless of whether or not they belong to the same project or the same organization. This can be super useful for organizations with several network administrative domains, as well as organizations that want to peer with other organizations. Network peering gives you several advantages over using external IP addresses or VPNs to connect to networks, including better network latency, better network security, as well as being a bit cheaper. Peered VPC networks exhibit the following key properties. It can work with Compute Engine, GKE, as well as App Engine flexible environments. Peered VCP networks remain administratively separate. Routes, firewalls, VPNs, and other traffic management tools are administrated and applied separately for each of the VPC networks. Each side of the peering association is set up independently. Peering will only be active if the configuration on both sides match. Either side can choose to delete the peering at any time. Peering can be configured for one VPC network even before the other VPC network is created. A given VPC network can peer with multiple VPC networks, but there is a limit. A subnet CDR prefix in one peered VPC network cannot overlap with the prefix in another peered network. This rule covers both subnet routes and custom routes. GCP checks for overlaps in the following circumstances and generates an error when an overlap occurs. When you peer VPC networks for the first time, when you create a static route in a peered VPC network, when you create a new subnet in a peered VPC network. Only VPC networks are supported for VPC network peering. Peering is not supported for legacy networks. There are new IAM permissions for creating and deleting VPC network peering. These permissions are included in the project owner or editor and the network admin roles. Once networks have been peered, every internal private IP address is accessible across peered networks. VPC network peering does not provide granular route controls to filter out which subset of CIDRs are reachable across peered networks. You're going to need to use firewall rules to filter out traffic if you need that kind of filtering. All virtual machine IPs and internal load balancer IPs are available in all subnetworks of peered networks. Static routes and VPNs are not propagated to directly peered networks. Only directly peered networks can communicate. In other words, if VPC network N1 is peered with VPC network 2 and 3, but 2 and 3 are not directly connected, VPC network N2 and 3 cannot communicate over this peering. Peering traffic has the same latency, throughput, and availability as private traffic in the same network. The billing policy for peered traffic and private traffic are both the same. Internal load balancing and firewalls, shared VCP, as well as multiple network interfaces per instance, and even IP aliasing are all available in VPC network peering scenarios.